Hello, my name is Corey Arnout, and today I'll be talking about our Week 10 assignment, document classification, me and my partner Jimmy. Um, First, we upload all the different libraries and packages. Second, we import the data. This is the spam data set that we're all working on. Load in the CSV, name all the columns appropriately, look at the first few rows of the data set here. Next, we explore the data, so some of the distribution attributes of the different columns. Next, we look at sort of of the mean for the target variable according to each column attribute. So you can kind of get a sense of, for example, what's a good one? Receive here. So while only 2% of legitimate, 2.1% of legitimate emails have the word receive, about 11.8% of spam emails contain the word receive. Money here, you see 21% versus 1.7%. So, word money might be indicative of spam. We split the data into a test and training set, build some different models. Here we have a support vector machine, k nearest neighbors, naive Bayes, decision tree, gradient boosting, and then a tuned gradient boosting model that I tuned below. I'll show you guys a little bit of that. So we run the different models through a k-folds through 10 cross-validations essentially, and then come up with the accuracy metric. And you can see that support vector machine did the worst, then nearest neighbors the next best, then naive Bayes, then decision tree, and then the gradient boosting and the tuned gradient boosting model did the best. So the tree-based methods definitely did really well. Here's the decision tree. As you can see, a lot of different nodes. There's a pretty elaborate decision tree going on. And then actually also the textual representation of the decision tree itself. So you can see, frequency of the $sign, how many times the word remove, frequency of exclamation point. Then it kind of goes down even further. Here I get into the gradient boosting machine here. I try out a bunch of different hyperparameters, so you can see a bunch of those, and you can kind of see for each one the accuracy score of the training and validation set. And then I just kind of looked at how they were doing. You can kind of see as the different hyperparameters are the learning rate, the number of estimators, so the number of trees, the number of features used in each tree, and the depth of the tree. Depth of 2 seemed to be best, so I did a little bit of trial and error before I, tried this one out even. But so you can kind of see as the gradient boosting trees get more and more deeper, I guess, with each tree and more trees, you can kind of see, like here we have a lot of depth, 1,000 estimators, 4 features, 5 depth, and you have really good training score, but then your validation score might not be as good as some of these other ones here. So like in here was kind of the sweet spot where we're really looking for where the validation score is kind of the best, because that's the data that the model hasn't seen. That's what we care about. And so that's the one I ended up picking. 3 features for the max number of features, 2 for the depth, 0.1 for the learning rate, and 500 different trees. And gradient boosting models seem to do really well. They kind of build off of each other in a recursive way, each time correcting for the remaining, residual error that was left over in the remaining tree. And then, so it's really interesting how they work, and they did really, really well here. You can get most of the way with a decision tree, or, maybe a random forest will do really well too. It's another aggregation technique, but gradient boosting models seem to do really well, with a lot of nonlinear relationships and also interactions between different variables. Anywho, so you can kind of see the precision matrix, or confusion matrix rather, and some of the different metrics here. One thing I will note is the worst is the recall, which is still 94%, and is indicative that we are missing some true spam. We're not actually getting all of the spam and classifying them. 6% of the spam are actually going unclassified as spam, so we might want to fiddle around with these models. Maybe we're more concerned with, the true the true positive rate and or capturing all the positives rather. So it's something to kind of consider. This is like what true positive over true positive plus false negative. So basically, how many of the spam are we capturing? And we're only capturing 94%, which is pretty good, but still. And so here, looking at variable importance for the gradient boosting machine. Basically, if you have, some of the most important features are having a lot of capital letters run together, having a lot of exclamation points, having a lot of money signs, the words remove, free, your, receive, credit, money, all those sorts of things are real indicative of that sort of stuff. And that's it. And that was our model. Thank you.